Okay, so it's 10 o'clock. Let's go ahead and get started. Last time we talked about sets and functions, and now we're going to move on to the next stage of gymnasia course, which is programming in Python. And as we discussed last time, the goal is going to be to provide a live class experience which is oriented around some practice, some interaction with classmates, and it'll give you a chance to hopefully discuss some ideas which may be interesting, which are not in the original lesson. But we won't be trying to go introduce the ideas completely from scratch, because if you try to do that, then it's really impossible to make the lesson engaging for everybody. And that's sort of what's been tried in the past, and it ends up going very slow. And I think it's better to rely on folks to fill in the gaps by working through some of the content asynchronously. So I want to give you a few Prismia updates as well before we get started. So the courses are now linked from the landing page, which might be a little more convenient than typing out that longer URL, just prismia.chat, and you'll see some course cards if you scroll down a bit. And that's going to be the Data Gymnasia curriculum for the summer. Last time there was an issue where folks set their, or rather folks who didn't set their call on me setting couldn't send messages. So I'll show you that again. So if you go to the menu in the top left and go to customize, you have a call on me preference, and I have it set to don't call on me by default. So you have to opt in, but I would encourage everyone who's in a position, where they are with their Zoom setup to be able to speak, and who's comfortable being able to speak, going ahead and setting that, because I would really like to start using that feature today, call on some people in class and get more student voices in the room. So put that on if you're comfortable. If not, that's fine. There's one other thing that I want to disclose up front, which has not existed before, but there's a new feature in Prismia, which I think is going to be really great, and we'll see. It allows me to see what you're typing as you're typing. So that's going to be true in the text box here if you're typing here. And it's also going to be true if you open up your Python cell. So things that are typed here, I'll be able to see as you're typing, and that way I can give you programming exercises, and I don't have the problem that I don't really know what's going on until the end when all the submissions come in. So we'll see how that goes. Okay, so yeah, maybe I'll throw in here just a chance for folks to ask questions. So any questions about anything you want to discuss before we get into the content? The suggested readings are the Data Gymnasia. If you want to read beyond that, there is an Airtable with other resources. So go to groundsci@github.io and look for the summer prep Airtable link. So there's a set of resources that are kind of curated there. It is a couple years old. I've updated it somewhat, but it was put together a couple years ago. It's going to be partly reflective of that. Does that answer your question? Is it Emery?
Yeah, thank you.
Yeah, cool. So no other questions came in, so we can just move on. Okay, so I want to start with maybe a bit of a fireside chat. So we're going to use Python for the summer program, and the reason is that it really is the clear canonical choice to use as a main language when you're first learning data science. And I'm curious whether folks have some thoughts from their prior experience on whether, or rather why that's the case. Yeah, so we have a few answers coming in here. So I want to share these so we can discuss them briefly. So yeah, there's a kind of a variety of ideas here, which is great. So yeah, so Python syntax is famously beginner friendly. That's a common point that folks bring up in these discussions. Yeah, languages like Java tend to be very restrictive because they're oriented towards building robust, large software projects, which is not necessarily the goal when you're doing exploratory data analysis. Friendly UI, easy to manipulate data. Lots of useful packages. This is a really big one. I think this is really honestly kind of the main thing. So yeah, let's talk about a few of these. So one that was not mentioned, although I guess it's sort of implicit, is that Python is extremely popular in industry. So people will consistently say that it's the most popular data science language by far, and that's based on various surveys that have been done of data scientists working in industry. We had our own survey of DSI graduates conducted recently, and that was also the case. I expected R to be kind of close behind, but it really wasn't. It was the vast majority of, essentially everyone used Python, perhaps in addition to something else, and a few people use R as well. So yeah, it's very popular, and that's an important thing because you will inevitably need to use it at some point in your career. And it also leads to a greater availability of libraries. And then also, if you're trying to get jobs and someone's like, look, we want someone who can get started quickly with Python, then that's going to be important. So R does have an advantage when it comes to statistics, especially the cutting edge of statistics. And that's because people and the researchers in the statistics community, when they write a new paper, they'll release an R package that goes with it. And it really is always R in that world. And so it does have an advantage there. In a lot of ways, also, I think the package ecosystem has some real advantages. But Python is going to be much stronger in everything else. So Python is a general purpose language. It's used, vastly outside the data science world. So if you're going to need to step outside of the bounds of data science and statistics, Python is going to have your back, whereas R really isn't. And even within data science, there's quite a few areas where Python has an advantage, like deep learning, for example. Julia, which we're also going to look at in the program in Data 1010, has some advantages as well, specifically when you need to build something that's very performance sensitive and also highly custom. So it doesn't fit naturally into the existing packages you can grab off the shelf. This happens quite a bit, actually, more than you would think. And people have other solutions to this within the Python ecosystem, but they're, famously quite challenging and quite messy. But, Julia's way behind when it comes to job listings and the library situation, I think, is a little unclear. There are a few packages in Julia that are important and better than other things. So the package ecosystem is actually quite strong, but it has many fewer packages by count. So a few folks mentioned this, and I'll offer a counterpoint. So people often say Python's big advantage is that it's easy to use and it's very nicely designed. And I think that's not really right. I think that R and Julia are both easy to use in very similar ways to Python in the sense of being high level and providing a lot of affordances and having a sane programming language design. And if you follow on social media, if you follow people who are really into programming languages, they often will roll out their criticisms of Python pretty liberally, and not a lot of them are kind of super fans of Python. There really are some downsides. It's not a perfect language. I think it's totally fine to acknowledge that. Speaking of social media, I'm just going to put in a plug for two people that I really like in case you want to start reading some social media writing about programming languages. So the first one is, I don't actually know how to say his name, but Tikan Jelvis, who writes on Quora. Used to write more, but still writes some on Quora. And then there's also Sri Ram Krishnamurthy, which is a professor in the CS department here at Brown. And he's just a super cool guy, very prolific writer. He has a blog and he's active on Twitter. If you're on Twitter, I totally recommend following him. He's a great guy. Okay, so anyway, I mentioned all that to say, as we start working through Python, there's going to be some aspects where like, wait a minute, this doesn't totally jive with the way I think about things. And that's fine. It's not like, that's anything wrong with you. It's just there are different ways to do things. Python represents one set of choices. It's not necessarily perfect, but it's fine. And more importantly, programming is really about getting things done. And part of the reason Python is so popular is that it's really great for getting things done, just by virtue of the availability of libraries and the fact that the language mostly stays out of your way and allows you to express whatever computation you're trying to perform succinctly, get an answer, and move on. Okay, so let's go ahead and jump into it. So as we talked about last time, In class, we're going to have these code cells that pop up, and we can do our coding here. And that's going to have some advantages for the classroom. Like, for example, you don't have to manage other windows. So if you haven't already done it with your little pop-up workspace here, go ahead and hit run on that. It's going to load the Docker. It's going to take a minute. Mine was already loaded, as you can see. But, of course, you're not going to be doing actual projects in a Prismia window. This is designed for the classroom. And if you want to handle larger projects, you need to use either an integrated development environment like VS Code or Jupyter Notebooks. And those systems are both designed to handle larger projects and help you get around your code and do what you need to do outside of the scope of one cell or a couple cells that we'll be dealing with in class. So my recommendation for folks, if you haven't done it already, is to go ahead and get Jupyter Lab working on your machine, as well as VS Code with the Python extension. So those things are really easy. Nowadays to set up, things have gotten, used to be a bit of a hassle, but it's gotten pretty straightforward, which is really great, because you don't want people getting discouraged right out of the gate when they're trying to learn things, just getting stuff installed. Just a little bit about the difference between these two things. So Jupyter is aimed specifically at a paradigm called literate programming, where the idea is you're going to interweave text, so like prose and maybe images, like whatever, like math equations, whatever is going to support the reader's understanding of the code there. So it's not just all code. There's context. There's other mental aids to help you understand what's going on. Whereas IDEs and Jupyter is sort of over time becoming more of an integrated development environment in this sense. But the goal of IDEs is less to have images and math equations that you can typeset alongside your code, and more to know about your code. So the idea is your editor is going to know the syntax and semantics of the Python language, and it's going to be able to use that to help you. So if you want to change a variable name everywhere it appears, Control F, if you think about it, is not a perfect solution to that. But if something can understand your code, it can do that for you and save you the time of going around and trying to find everything and touch it up in the right way. And it can do a lot more sophisticated refactoring than that as you go on. You can imagine that the editor is like your assistant that knows about the structure of what you're working with and is able to kind of give you a boost that way. So for my 2 cents, I think knowing both Python and VS Code is totally worthwhile. I think you don't want to just pick one or the other and stick with it. You want to start from the beginning, trying to learn both and using both in appropriate circumstances. But that said, we're going to be able to stay in the browser today, so we can just move on from that kind of preliminary discussion. And with that said, I want to open up with a question that will maybe get a chance to, if you haven't thought about this before, it's kind of a helpful thing to think about. So when you are interacting with a Python prompt, so that's called the REPL, and it's a program that runs on your computer. You have to start the program, and then it accepts text, and it executes your code and returns some sort of output to you. So the question is, what does that program have to keep up with in order to do its job? What are the kinds of things, if you wanted to build a program like that, what would you need to be building into the program that it can keep up with so that it can do its job? Okay, so I'll start sharing some of the answers. So this is a great answer. So the user-defined object. So when you define an object in the program, it has to keep up with that. So for example, if you say x equals 3, then the Python session has to remember that information for when you use the variable x later on. So user-defined objects, yep. And then also libraries. So the program has to know about any libraries you might have pulled in, and also it has to know about all of the built-in functions that the language allows you to use kind of, whenever and wherever you want. Yeah, so this is kind of a bigger one. Let's try the student voices in the room thing. So Mark has this check mark here. Do you want to elaborate on your answer, Mark? So here's another one that Yash mentioned, which I guess it's sort of been implicit, but it hasn't exactly shown up in the other ones. The program has to actually read what you type in and make sense of it. So it has to have the syntax of the language built into it. In other words, it needs to be able to take the string, the sequence of characters that you sent to it, and parse it, figure out what you meant by that, and then actually execute that code based on the meaning that that syntax corresponds to. So one other thing that wasn't mentioned is types. So the program also needs to be able to keep track of the type of each object. So like when we said x equals 3 here, it needs to remember that we did that, but it also needs to know that 3 is an integer as opposed to some other type. So when Python stores this, it's going to have to keep track of the underlying bits, the ones and zeros that represent the 3, but also the type. I want to ask, why is it important for Python to know the type of every object? So sometimes people say Python is untyped, types don't really matter. That's not true. Types don't matter necessarily so much to you, but the program definitely has to know the type of every object to be able to use it. Why is that? So here's Luke's answer. Luke, would you like to elaborate? Yeah, that's right. So the types really dictate a lot about how the program behaves. But even more fundamentally than that, as we just mentioned, the object is ultimately stored as ones and zeros in your computer's memory. And ones and zeros by themselves mean absolutely nothing. There has to be an extra layer of meaning that we put over the top of those ones and zeros that tell us how to interpret them if we want to make sense of the data in any human comprehensible way, like mapping it to a particular text or number or image to display. You know, there has to be a specification for that. Okay, here's another kind of thinking question. If you haven't thought about this before, it's kind of worth thinking about. So what are some ways in general that we can get objects into our program? You start with a blinking cursor in your empty file. You have to start getting objects into the program to manipulate them. And there are multiple ways to do that. What are some thoughts? Okay, great. So lots of good answers here. Actually, there was one I sort of forgot, so I'll add that into the discussion. So let me summarize this block so you can see what everyone said. Yeah, so we have this category. We can just type them directly into the program. We'll talk about that in a second. You know, it's the same answer as this one. We can build our own objects directly. We'll talk about that a little bit. This was the one I missed. You can pull objects in directly from packages. I normally don't think of that one so much because usually we're pulling in functions from other packages. Well, I guess the function's an object too. So yeah, that definitely should be included. And then reading them in from disk. So you have some data that's stored in some non-Python format, like a comma separated value file with a spreadsheet or just some plain text files or whatever. So that was good coverage in that bunch of answers. So yeah, so I'm going to say there are basically 3 ways. I'm going to add a 4th one. So we can type code directly in that the system interprets and returns a value based on that. So for example, in the specification of the Python language, you can enclose some text in single quotes like this, and that returns a string. So we can type it directly in, and that has a name. That's called a literal. So this, for example, is a string literal because we're getting a string into the program that way. You can also type, integer literals, float literals. So those are both numeric types. We'll talk about sets and dictionaries. There are literals for that as well. But there aren't literals for everything. So for example, Python has dates. Of course, you'd want your programming language to be able to handle a date object, but there's no special syntax for that. We have to call a function, which lives in this datetime package, and it will return a date object for us. But this is getting an object into the program through calling a function. So this is the same category of answers as these two, creating classes. We can manually define our own classes. So we'll talk more about that later on. And then the other one that folks mentioned is getting objects into the program by reading them in from a hard drive or from the internet or just somewhere else. So we saw this last time. You can use pandas to pull directly from a URL. So if you type a URL as a string pandas will go grab the data that are there and bring it in as a table into your current programming environment. And then, yeah, the other one, we can also import objects from libraries. So it's really 4. I just kind of missed that one. I don't know. I might be missing other ones too. Not necessarily intended to be an exhaustive taxonomy, just to start thinking about, what are kind of the different ways that we can interact with Python with respect to getting objects into the session. Okay, so the second section is in the Data Geonesis course is functions. Let's talk about that just a little bit. And instead of introducing them from scratch, what I want to do is just elaborate on a point that we discussed a little bit last time. So here's an example of a Python function. So we're defining f of n, and we say whatever the input n is, return a plus that input. So, and by the way, you'll find me sticking strings at the end of blocks of code like this sometimes. That's purely because of how these code cells inside of Prismia work. If you don't have that, it'll say loading or nothing returned, because it doesn't get a response back from the server, because in Python, when you write a definition statement, it doesn't send anything back. And it's kind of annoying to see this loading sign here. Maybe one day I'll fix that, but for now I just put this at the end. In any case, what requirement of a mathematical function does this Python function not satisfy? Oh, so this is a good one that I didn't think of. So Tong, do you want to elaborate on your answer? Yeah, this is this kind of touches on a broader point with Python. So I wasn't thinking of this angle on it, but that's a really good point. So this is an issue in general with Python functions. So the implicit domain with any Python function is anything you want to throw in it. So if you call f of absolutely any object in the Python language, it will try to do something with it. And if it encounters a problem, like if it realizes it can't add what you put in there to A, then it will throw an error, which you would want it to. But unlike some languages where you can effectively specify a domain by saying what type of thing the argument needs to be, in Python you don't. So this is called duck typing, with the idea being that if it walks like a duck and quacks like a duck, it is a duck. So you throw anything you want in there, and it tries its best to do something with it. And if it behaves appropriately with respect to the operations inside the function, you will get some kind of output from it. So yeah, so that's an issue. There's no domain here being specified. There's another issue. Nick is making a point. You want to elaborate on that? Is it Nick or Nicholas? Sorry. So yeah, you could do that, but this sort of business in Python where you sort of like write type checks in, I've never seen it done really at all, honestly, but definitely in serious projects. If you really want to do type assertions in Python, you want to use a feature it has called type annotations, where you can tell it, you can put in a colon like this and tell it this should be an integer. The language itself doesn't do anything with that, though. That's just for you to help you understand it. But yeah, it would implicitly define a domain if you made a type assertion on the first line. It would be clear enough to a reader that's the kind of object you have in mind for this function to act on. So, well, the answer is it depends. So it is fine as a Python function. I mean, as you can see, we executed this block and didn't throw an error. It was completely fine with all this. And the reason, so before I run this next line of code, I'll just type it in here. So you're right that if we say like, what is f of 3, it will say, I don't know what a is, you haven't defined that variable. But the thing is, if you do define a, then, which you of course would if you wanted to use this function, if you do define a, Python will get it from the surrounding environment. So it knows that no a is defined here, so it goes outside of that to the global workspace. So the kind of top level where we're defining variables when we run lines of code here. And if a is defined, then it will do something with it. So if we call the function to say what is f of 3, print that for us. And by the way, we just set a to 1, then it will print 4. And if we had just set a to 2, then it'll print 5. So it is fine as a Python function, but we say that it depends on the program state. So this is something that exists outside the function. and nevertheless affects the way the function behaves. And this means, for example, that this function can't just remember what it output last time for a given input and just return that same value again. It has to do its computation fresh because it might be getting some values in there that have changed since the last time it was called. So a function that does not depend on or modify any program state is said to be a pure function. And that's much more like what we're talking about when we define a function mathematically. On the other hand, from a certain perspective, a mathematical function and a programming function are not really the same kind of thing in the first place. So a mathematical function is an abstract relationship between two sets that assigns to each element in the first set some element of the second set, while the second is a packaged block of code that can be called upon wherever you need it in the program. So framed in those ways, they don't sound like the same sort of thing. There's some correspondences, and of course we use the same terminology because there's enough overlap in concept there, but they are different. And the reason that functions are important in programming, so programming functions are important, is that you really want to be able to reuse code when you program. So I want to give an example that's sort of not in Python space, just to approach this conceptually. So if you look at these buttons in your toolbar, they have a lot in common. For example, the spacing they're supposed to have on the left and right, their vertical alignment, how big they are, etc. And you wouldn't want to, if you were designing the system to display those four icons, you wouldn't want to have to write the size and alignment and all that every single time you want to put a new icon here. Because then if you want to change it, you have to change it in multiple places. It's easy for mistakes to start creeping in when that's your workflow. So what you do instead is you'll just have a single function that is responsible for rendering a button, for outputting the data that the browser needs to say what that button should look like. But of course, the buttons aren't the same. They do look different in some ways. So there's some similarities that you want to have in one place, but there's some differences that you want to be able to account for as well. And like, so, you know, for example, of course, the icons are different. The behaviors are different. Like if I have text here, this one has to turn green and the other ones don't. So the way that we handle those differences is by making them parameters for the function. So these are the values that we specify to the function so that it can perform the task that it's being called on to perform. So the things that are common to all the inputs can be handled one time in the function's body, and the things that are specific to the different types of inputs that we might give it are going to be specified in the parameters. And so this ability to sort of bring together things that are common and things that are distinct and manage them in a reasonable way, functions do that well, and that's why they allow us to build complex programs that are still maintainable. So each function's responsibility should be comprehensible and manageable in that one place where the function is defined. And that way, if you need to update it in some way, you only have one place you need to look at. All right, so let's look at an example in Python. So suppose we want to solve quadratic equations. So equations like x squared minus 2x plus 1 or x squared plus 7x plus 12, either equal to 0. So which aspects of the problem-solving process are going to be common to all such equations? So these are the things that are going to need to live in the function body. It's interesting here. I don't see any answers in the block that I would really say are correct. So people are keying in here on the equations themselves. So like the minus and the plus and the equals and the x's, those things are not really part of the solving process. So we're going to be able to write this program in such a way that it never touches an x. You know, and this equals also doesn't really matter. We're going to need to be able to extract some data that specifies this equation and then do whatever it is that we need to do with that data to produce an answer. And there is a way to produce an answer generically to a quadratic equation. And now some people are coming in with that. Right. So the quadratic formula is what we want to use here. And that's what's common. So we're going to use the same quadratic formula for any equation. That's the point of the quadratic formula, is that it works no matter what the particular equation is. So it's not like the quadratic formula is the only way to do this, but it is, I think, the canonical way to do it, and it's a very reasonable choice. So the body of the function is going to contain logic with the quadratic formula in it, and then just need a way to specify what's different about one equation or another. So minimally speaking, what is the data that you need to communicate to say which quadratic equation you're talking about? Okay, folks started coming through on this one. Yeah, so the coefficients of the variables, that's what's key here. Just the coefficients A, B, and C specify the equation, so we're going to make those parameters. All right, so here we go. So we need to get the square root function. We can get that either from math or from NumPy, but we're going to get so much stuff from NumPy, we'll just get in the habit of that. So we're going to define our function, call it quad solve. It's going to take 3 parameters, A, B, and C, which are going to specify the equation. And then we're going to return the solutions. And I just typed in the quadratic formula right here. So I paused for a minute to see if someone would object, but I'll give it away. There's some issues here, and I want to kind of work through them together so we can practice thinking about like the difference between a well-written function and a poorly written function. So looking around at what I've written here, what are your critiques? Okay, so this is a good one that folks are keying on. So Radhika, do you want to elaborate on your answer here that I'll share now? Yeah, that's good. So that's a good one. We are going to do that. Yeah, there's some duplication of effort here, some inefficiency in repeating this code in 2 different places. So yeah, that's a great one. Here's another one. You can get imaginary numbers. We haven't really accounted for what's going to happen if this is negative. What does NumPy's square root function do? We're going to have to figure that out. I'm a little surprised. No one has spotted the really big thing. So there's something really bad here. Go ahead, Mark. So if you look at this, like, let's focus right here. What mathematically does that mean? I mean, this is wrong. Yes, the division happens first, then the multiplication. So A is in the numerator here, effectively, because we're multiplying by A. And then addition happens last. So that's order of operations. And so this is just all messed up. This looks sort of plausible because in your mind, you will supply the parentheses in the appropriate places, but Python has no mind. It will not supply parentheses. It will do exactly what you told it to do. And so we've got to fix that. So yeah, that's number 1. So here it is with that part fixed. So we group the denominator, we group the numerator. Now it's at least mathematically correct. Another thing that's missing that also wasn't mentioned, which is fair enough because it's not so clear it's in scope, but in data gymnasia, this is emphasized a lot. We should write tests to make sure that it does what it's supposed to do. You know, if we just look at it and think it's right, it's very easy for us to be wrong. We overlook things very easily as humans because we have blind spots. That's why your brain is great at doing what it does. It elides lots of things that it figures out that it can ignore. And in programming, that can really, I mean, it's essential, but also it can really bite you. And so test-driven development, where we write tests as we go, is the way we get around that. So we try to catch mistakes immediately by testing small pieces of functionality to make sure that they do what they're supposed to do. So I've written the test underscore quad solve function here. This, by the way, it's not actually totally arbitrary, writing test underscore, because what you can do when you're maintaining a large Python code base is write your tests like this, and then you can manage the code base with a testing package that respects this convention. So whenever it sees a function like this, it knows that's part of the test suite, and it will run it and make sure that everything works out. Incidentally, I did have to right here sort the output because we're returning a tuple. We're returning 2 values, but like it's still valid if they're in some other order. Like the order doesn't really matter. So we have to have some way of telling Python, like, check if these 2 things are equal, but like the order doesn't really matter. So one way to do that is just to sort the output and make sure that it's equal to the correct 2 values in the correct order. So we run this and our tests pass. So really, you know, you might want to write more tests than this just have a couple for the purposes of the lesson. But at least probably we're not making some egregious mistake, at least for these basic examples. Another thing that's missing is a docstring. So we really should, ideally, we should write a docstring to tell folks what the program, what the function is doing. So that's going to be a string literal that's on the first line, or really, the first non-empty line of the function body. And that's also not just, that's not arbitrary. The Python actually will interpret such a string literal as the docstring for that function, and then you can get it later when if somebody is using your function and wants to ask Python, like, hey, what does this do? The help function will access this docstring. And then the last one that I had in my list is the one that folks really keyed in on, which is just make it a little more efficient by computing this. It's called the discriminant. That's why it's denoted delta here. And we can compute that just once. And that makes our code look a little tidier. And it's also more efficient because we don't repeat this computation. Of course, our tests are still going to pass. Okay, so this is good to note for next time. We will have made it through about 60 messages today. So I have some more content. We'll just use that next time. But we do have 5 minutes left, and I want to spend 3 of those 5 minutes working on an exercise. So this is just a small programming exercise, and I want everybody to give it a go at it for 3 minutes before we bring it together and discuss it. So the idea is we want to write a function that just extracts a person's initials from their name. So for example, if we call our function on Robert Johnson, it's going to give RJ. If we call it on Rosetta Tharp, it's going to give RT. Yeah, I'll avoid elaborating more on that. So, but do your best. You can grab the text like this, pop open your workspace, and delete the pass keyword here. See what you can come up with. And by the way, when you have a solution here, you can just paste it into your solution box, and you can also do 3 backticks and a space to get a code block to make it look nicer. Because I think maybe some people have solved it, but I haven't sent messages yet. Yeah, so when you type the backticks, you do have to hit a space to turn it into this code block form before you then paste it. If you put the ticks and then paste, then and then hit space, it won't work. So it's like the 3 ticks are just sort of a shorthand for telling the system, like, hey, I want to be putting code in now. Okay, so do you want to talk to us about your answer? Cool. Yeah, so I guess the one thing I see here is when you add these 2 first letters together, it seems like maybe that's already what you want. I think this is going to be fine as well, but yeah, you're using the addition sort of instead of the join here. So that's fine. It's just kind of a different way to go about it. That's good. I want to share what everybody did because we're out of time. I just want to make sure folks have a chance to see the range of things that people did. It's going to be too much to kind of look through it now, but just kind of for posterity, it's there. And yeah, for completeness, let's just leave it for next time. So this is what folks did. Next time we'll pick up with kind of walking through the solution a little bit. And then we have some more exercises queued up that are going to get kind of progressively more challenging. And I have an 11 o'clock meeting, so this time I have to run, but in general, I'll be sticking around for a few minutes. So our next meeting is next Tuesday. So thanks everybody, and I look forward to seeing you next time.
Thank you. Thank you.